Hello, this is Dr. Mears, and today we are going to be learning about the product rule, which is another rule for differentiating equations. When we look at the product rule, what we're going to see is we're going to have a couple more variables. So instead of our normal x and y variable, we're actually going to have u and v. And u and v are going to represent two different functions. U is going to represent the first one, and this is a v. V is going to represent the second. When we differentiate, we're going to have to keep the first one the same, differentiate the second, and then add that to keeping the second one the same and differentiating the first. And that's what the box says down here. To explain these, I'm just going to use the example. I think this is easier to learn using the example than looking at an entire formula. So let's get started. Here's our example. Use a product rule to find the derivative of these functions. Part A, f of x equals the quantity x cubed plus 3x squared plus 6 times the quantity 2x minus 1. So we have a u and a v here. What are they? Well, this first function right here, that's a u. The second function is v. And so it's just kind of like we have the first one, second one, this is number one, this is number two. So if you want to think about it like that, that's fine. When we differentiate this, what we're going to do first is keep the first one the same. So I'm just going to write down exactly what's in the parentheses. X cubed plus 3x squared plus 6. That's it. Keep that one the same. Just rewrote it. Then what we have to do is differentiate this second one. So we have to take the derivative of 2x minus 1. The derivative of 2x is 2, and then the 1 drops out. Okay, now we have to add that. The next thing that we have to do is differentiate the first one. We didn't do that here. So now this next part, we have to differentiate this one. So each part needs to be done. So x cubed differentiated is 3x squared. Positive 3x squared differentiated is positive 6x, and the 6 drops out. Close parentheses, and we just bring down the v function, which is the second function, 2x minus 1. So you'll see here, this is the first function, this is the second function. This is the derivative of the second, this is the derivative of the first. If you can keep it in that order, we're good to go. Now, a lot of college professors and high school calculus teachers love for you to multiply everything out here and combine like terms. So that's the next step that I'm going to be taking. So we did the product rule. This is the product rule. Now we're just cleaning it up a little bit. So first, I'm going to distribute this 2. So x cubed times 2 is 2x cubed. 2 times 3x squared is positive 6x squared. And 2 times 6 is 12. Okay, that's done. Over here, I'm going to multiply these out. I am going to be multiplying 3x times 2x, and that's going to give us a positive. Now remember, these have exponents of 1. When we multiply the coefficients. 3 times 2 is 6. We add the exponents. 2 plus 1 is 3. So multiply the coefficients, add the exponents. So 2 times 3x squared times 2x is 6x cubed. 3x squared times negative 1 is negative 3x squared. That's done. Now let's distribute this. 6x times 2 is positive 12x squared because 1 plus 1 is 2. And then 6x minus 1 is minus 6x. Okay. Now we have some like terms. Like terms have the same exact exponent. So I see a like term here, 2x cubed, and here, 6x cubed. 2x cubed plus 6x cubed. We're just doing 2 plus 6. 8x cubed. I can get rid of those two. All right, what are other ones? We have positive 6x squared, negative 3x squared, positive 12. So all we're going to do is 6 minus 3. 6 minus 3 is 3. 3 plus 12 is going to be positive 15x squared. That's all I did. All I did in my calculator, all I did was I did 6 minus 3 plus 12, and I get 15. That's it. And then don't forget to bring down your x squares. So that's out. All those are out. And then I have a 12 and a minus 6x. They are not alike, so all we do is we just bring them down. So we bring down the 6x first, and the 12 goes behind. So Our answer is f prime of x equals x cubed plus 15x squared minus 6x plus 12. This is where we use the product rule. This is where we just simplified from here to here. Okay, multiplied and simplified. All right, let's look at another example. Example part B. So we have we see that we have this square root. So before we do anything, before we assign any u's and v's, let's get rid of that square root. So this square root is going to be turning into a exponent of 1/2. Okay, perfect. And this is multiplication here. So we have the first function, u. We have the second function, v. Let's use a product rule to differentiate. Y prime equals, we keep the first one the same, so we just bring down that x squared. We have to differentiate this one. So 1/2 times 1 is 1/2, parentheses, x squared plus 1, and our parentheses raised to the 1/2 minus 1, and that's going to be negative 1/2. Now we're not done yet because, and I'm going to do this over here, this is part of the chain rule. This is where it gets this is where calculus separates everybody, because you have to remember, we have a chain rule here. We have an inside part and we have the outside part. And so what we just did right here is we differentiated the outside. We did this whole thing. We still have this inside part to do. So while we differentiated the outside, we still have to multiply by this part in here. So 2x squared becomes 2x, and then this drops out. This is the tough part, is remembering if we have something raised to an exponent, then we're going to have to do the inside and the outside, and our parentheses, plus. Okay, now we have to differentiate x squared, which is 2x. And we keep the second one the same. Okay, let's do a little cleaning up here. So first, I look inside right here, and I see that I can multiply the 1/2 times the 2x. So I'm going to have y prime equals x squared times 1/2 times 2 is 1, times x squared plus 1, the negative 1/2. Okay, and then here I can't simplify anything. And I'm going to put some square roots back in because I want to take out all of my exponents that are fractions. So y prime equals x squared, and this is going to be times x squared minus 1. And this is actually negative, so how can we write that? This is actually negative, so what happens? So it goes underneath, so we have x squared plus 1, and that leaves these two, so I'm going to be able to do something with that. Plus here, this is going to be 2x, we're going to change that, times the square root of x squared plus 1. So I just made this into a square root. And this one, negative, so I left this on in the numerator. I just brought this down and changed it to a square root. There's one more small step that I can take. I can multiply these. When I multiply these, I add the exponents. So this is really going to become x cubed over the square root of x squared plus 1 plus 2x times the square root of x squared plus 1. Put a little box around my answer so that you don't get confused. And that's my answer, nice and simplified. So there was something that you had to remember, and that's this, using the chain rule. So inside, when we did the product rule, you had to use the chain rule, and then here I just simplified. So this is remembering those small things. Okay, speaking of remembering, let's do a little review for number 2. Number 2 says, this is a little review. We have to find the equation of the normal to the curve. This brings it all together. This is using everything that we've learned from differentiating into one problem. So this is going to be a bigger problem. You might want to take a little break and just make sure that you understand each step. So when we find the equation of the normal to the curve, the first thing that we're going to have to do is take the derivative. So Here we see that we have the equation y equals square root of x plus 1 all over the quantity 2x plus 1 raised to the third power. X can't be negative 1/2 because if we put a negative 1/2 in, we wouldn't have an equation anymore. The denominator would be 0. So this is just telling you we can't have x equaling negative 1/2. They give us that point. Here's our x, here's our y. And so let's take the derivative of this function. Before we do, though, what do I want to do? Yes, I want to get this out of the denominator. So y, whoops, we're not even doing y prime yet. We're just doing y equals the square root of x plus 1 times 2x plus 1 raised to the negative third power. Okay, what else do I want to do? You're right, I need to get rid of the square root. So before I can do anything, I have to change this into the power of 1/2. This is 2x plus 1 to the negative 3. We already can see that this is going to be a little messy because we have these negative exponents and we have fraction exponents. So we just have to be careful in our work. So now we're ready to take the derivative after we kind of cleaned it up a little bit or did the necessary things. Okay, so we have to use the product rule here. So here is the first one, u, and here is the second one, v. Now, yes, you're absolutely right. We have to also, because we have these exponents, we are going to have to use the chain rule for each of these. So let's do a couple things. So for our chain rule, I'm going to write on the side. So the first one for our u, here we have x plus 1 raised to the 1/2. Let's take the derivative of just this. When we do, we take the derivative of the outside. So it's going to be 1/2 to the x plus 1 all raised to the negative 1/2. All right, and then we take the derivative of the inside. So the derivative of x plus 1 of x is just 1, and then the 1 cancels out. So our du dx for this is just this 1 times 1/2 is just 1/2 x plus 1 the negative 1/2. Okay, perfect. Now let's take the derivative of v, and this is just going to make our work much easier. So let's take the derivative of this one. So this is 2x plus 1 to the negative 3. When we take the derivative, first we're going to do the outside. So this is a 1. Negative 3 times 1 is negative 3. Keep the inside the same. 3 minus 1 is negative 4. Then we have to take the derivative of the inside. Derivative of 2x is 2. The 1 cancels out. Now I just clean it up a little bit. I just multiply these two. Hopefully you can kind of see that we're doing the same steps, but just for different numbers. Negative 3 times 2 is negative 6. This is 2x plus 1 to the negative 4. Okay, so I'm going to be using this one, and I'm going to be using this one. So now that I realized that I had to use a chain rule, and I had to use a chain rule because I saw these exponents here, and we have an inside version raised to an exponent, I had to take those derivatives. So let's now use the product rule. So when I did the derivative, I did the chain rule first, and then I'm doing the product. Okay, so y prime equals, when we use the product rule, we keep the first one the same. We keep u the same. X plus 1 raised to the 1/2. Then we take the derivative of the second times the derivative of the second. We come down here. That's the v. Come down here. We're going to put this in. Negative 6 times 2x plus 1 raised to the negative 4. Perfect. Plus. We keep the second one the same. 2x plus 1 raised to the negative 3, and we take the derivative of the first. We have the derivative of the first. It's right here. 1/2 times x plus 1 raised to the negative 1/2. That's it. So we're mainly now filling in from the work that we did here. All right. This looks a little messy. Let's clean it up a little bit. Let's put some square roots back in. Let's put things in the denominator if we have negative exponents, just so that it looks a little bit better. So we have y prime equals square root x plus 1. Then we have times 6, and this is times negative 6. This is not raised to a negative exponent, so I can put it in front here. Negative 6, so that 6 goes right in front. This is a negative exponent, so it's all over, oops, I forgot the little 1, all over 2x plus 1 to the 4th power. Okay, that took care of this. So the negative brought it down here. I've got that little 1, so I put it back in. The negative 6 stays in the numerator, doesn't have a negative exponent. This doesn't have a negative exponent, so we just kept it in the numerator as well. Plus, what does this go? You got it, denominator. So 2x plus 1, whoops, I always keep raised to the 3rd power. Now it becomes positive. Oh, we also have this 1/2. So now that this 1/2, the 1 can be in the top, the 2 is in the denominator. And that also goes in the denominator as an x plus 1. So my 1/2 came in front, and I can actually write my little 1 right here, okay? Right in the middle, because nothing else is on top with it, so I can erase that. So my 1/2, that's done. Negative, my 2x plus 1 to the negative 3 came down here to become positive. Negative again, so I brought it down here and I just changed it to a square root. All right, looks a little better. What do we have to do now? Now what we have to do is we have to find the normal to the curve. And normal is going to be perpendicular. So perpendicular slope. So we have to, for our second, so our first thing was to take the derivative. Our second is to substitute x equals 0 into this derivative. So y, so happy they use 0. Y prime equals negative 6 times the square root of 0 plus 1 all over 2 times 0 plus 1 to the 4th plus 1 all over 2 times 0 plus 1 to the 3rd times 0 plus 1. You could do this in the calculator, absolutely fine. The square roots, this is just going to be the square root of 1. So you're going to come out with a y prime of negative 11 divided by 2. The reason why I kept this in a fraction is because I need the perpendicular slope. So the slope that we're going to use is going to be positive, and then I'm going to flip it 2 over 11. So this is the normal to the curve, okay? So we had to flip this. One more step, and that is going to be for number 3. Third step, we're going to substitute into y minus y1 equals mx minus x1. So we have our point. Here's our y1, x1. We have our slope. So this is going to be y minus y1 is 1 equals 2 over 11 times x minus 0. Which is really nice because this happens to be y minus 1 equals 2 over 11x. And then we're going to add 1 to both sides. And we're going to get all the way down here. Y equals 2 over 11x plus 1. And this is your answer. Woohoo! So yes, if we look at it, this is a lot. First, we had to take the derivative. And when we had to change it so we have exponents, we have negative exponents, and we have fraction as exponents. When we take the derivative, since we have these exponents, we had to use the chain rule. So I did my work so that I had my derivatives all ready to go. Once I used my chain rule, I then could use my product rule, and that's what I did at this step right here. This was my product rule, where I was able to use this and just substitute them in. I then cleaned it up a little bit. Got rid of my 1/2s, made them into square roots, took my negative exponents, put everything in the denominator. After that, I substituted x is 0. I got that from up here. Whatever number this is, that's the number that you're going to substitute in. Okay, it's the number given. So don't think it's always 0. It's the number given. They gave me 0, so that's the number I put in. I used my calculator. I came out with negative 11 over 2. They want the normal slope, which means I had to take the opposite, positive, reciprocal, 2 over 11. Third, lastly, I substituted the point they gave us, 0, 1, and our slope, 2/11, into the formula, simplified, and I got my answer, my normal to the curve, y equals 2 over 11x plus 1. This is a calculus problem. It is. It does have a lot of steps and a lot of work. Take it slow. I hope this helped. Have a good day.